Hi everyone, my name is Thomas Kim. Today is December 30th, 2019. This is my 67th episode about linear algebra and threading building blocks. In this episode, I will discuss how to make best use of modern C++ language, and I will make a bug fix for complex metrics. Also, we will learn how to put constraints over C++ type. C++20 standard introduce concept. If you want to learn about the C++20 standard concept, please double-click this link and watch this series of videos. I filmed 12 videos for C++ standard concept, but I found C++20 standard concept is still not perfect. We still need template metaprogramming using type functions. So I created C++ template metaprogramming video series 44 videos. If you are interested, please double-click this link. In C++ template metaprogramming series, I filmed 44 videos. This is the most fundamental concept about template metaprogramming. In case of C++ type functions and modern C++ programming 30 episode, this series is a little bit more advanced. I introduced the concept of type list through this series of videos. Starting with episode 24, episode 25, to the end of episode 30, I introduced type list and compile time loop. The concept of type list and compile time loop is very important. Also, the future of C++ programming, C++2A standard, I filmed 65 videos. This is also about C++ modern programming. I highly recommend you this series of videos. In case of graph in C++, in this series I filmed 34 videos. I think this series is also very much advanced. But I teach fundamentals of modern C++ programming, also advanced C++ programming. For example, in episode 18, I introduced SDD beast, SDD variant, mixin, static polymorphism. C++ language is very complex, but it is not insurmountable or insuperable. If you understand the fundamentals, you can understand the C++ language. So never neglect to learn the fundamentals. Learning the fundamentals is more important than learning the application. Once you have a solid understanding of the fundamentals, you can implement almost any algorithm. Through this series of videos, linear algebra and threading building block, I emphasized the importance of recursion. Also, I introduced proxy class and indirect indexing. These are pretty much advanced concepts, but once you become familiar with these things, implementing advanced algorithm becomes much bearable and simpler. In this episode, I will help you understand how to put constraints over C++ types. This episode continues from my previous episode. In the download source code section, in episode 66, please double-click this link. Show in folder, unzip the downloaded file, right-click, rename 67 complex matrix and constraints. I made typo. Constraints. Copy. Paste it to your working folder. Start Visual Studio Code. Open the folder. Expand. Complete pivoting. Ctrl V. Ctrl N. Scroll up. Starting from 479. Select up to this point. Copy. Paste. Scroll up. Test complete pivoting with complex matrix. Now element type is SCD, complex double. Now copy the function name, scroll down, paste it here, disable it, Please understand that in my programming, I almost never use type explicitly. Other than size t, the index type, I almost always use using type alias. Simply modifying one line of code in element type, all program changes to something else. Now start command prompt dir cd 67 complex matrix and constraints clang std c++17 complete pivoting .cpp ltbb malloc hit enter. So we have an error message, long list of error messages. Error occurs at line 2328. So 2328 in this file, Ctrl V, Ctrl G, 2328. This is causing the error. So our type is value type. Value type. I simply modify this part, then we rebuild. CLS. Now our elements of the matrix is complex number. Successful true. Solution is given as complex number. This is the power of template metaprogramming. Also, I found I made a bug. Absolute value. In this function, unsigned integral type, it should be signed integral type, because signed integral type support negative number. Now we build once again. Of course, it should work successfully. dir cpp b. Now I will make a type list. Test build txt. Open Explorer. Double click. We don't need a template. Delete it. clang std c++17 copy. Now here ltbb malloc o c1 copy paste. Now c1 c2 c3 c9. Now go to file, save as, test build clang cmd, save. Now file once again, save as, test build with GNU, save. Now copy this, G++, replace all. Now G1, G8, G9. File, save as, MSBC, save. Now it should be copy CL EHSC STD C++17. Replace all. It should be TBB malloc .lib fe. Replace all. Now it should be M1 exe, M2 exe. I will just copy M1, M2, M3, M8, M9. Now open this file once again. It should be exe C1, C2, C3, C4, C5, C6, C7, C8, C9. Open this file too. exe G1, G2, G3, G4, G5, G6, G7, G8, G9. Now in the command prompt, cls test build, clang, cmd. So all programs build successfully. C9 exe. I made type here. Now in GNU, test build, GNU, hit enter. GNU also builds successfully. Now let's try with Microsoft. CD 67 complex matrix and constraints. Test build, MSBC. Microsoft compiler also succeed, M9. Now close this CMD file, this CMD file, this CMD file. In complete pivoting, Control N. In this function, matrix, scalable fast matrix, unsigned, UM. In the command prompt, CLS, clang++, std, C++17, complete, pivoting, .cpp, LTBB, LTBB, MALLOC, hit enter. It builds successfully, but I want to disable unsigned integral types from matrix to the class. That is, in this matrix 2D class, I want to allow only signed integral types and float, double, long double, and std, complex float, std, complex double, std, complex long double as the element type of the matrix 2D. How? This is so-called constraint over type. Now scroll up. Right after talk play fun namespace matrix, here using allowed element types. Types, type list, T. I will not allow character type. I will allow signed short, signed int, signed long, signed long. These are signed integral types. Float, double, long double, std, complex float, std, complex double, std, complex long double. Now here, template, type name, type name, talk play fun, remove, cb reference t, type, context pair, bool is allowed, type b, types is in list b, type name. We provide this type, allowed type. Template, type name, element type, using enable if allowed type t. std, enable if t. We use this type function, element type. Control home, Control F, class matrix 2D. This is forward declaration. Here, type name, dummy type. Here, aligned safe matrix T, enable if allowed type, element type. copy this, paste it here, comma, paste it here, comma, paste it here. Now scroll down. Here, type name, dummy, type. Paste it here. Don't forget this part. Scroll down. Here, type name, dummy, type, equal, enable, if, allowed type, element type. Now, in the command prompt once again, we should have error message. Scroll up. Here, I don't think we need this. I will delete this part. Instead, here, enable if allowed type, element type. I will fix like this. It should not build successfully. It should fail. Okay? It fails. Now, here, if I disable it, then it should build successfully. Okay? It builds successfully. For example, if we try to declare matrix 2D unsigned long ULM, it should fail because unsigned long is not allowed. It fails. The C++ compiler says template argument 4 is invalid. This does not work. Let's try with Clang compiler. What does Clang says? Also Clang says this part. Okay? Now if we disable this part, it should work successfully. It works successfully. CLS. Now we try all programs. dir cmd. We test with Clang compiler, build Clang. So Clang compiler works successfully with GNU. GNU compiler also works successfully. Finally, with the Microsoft compiler. Microsoft compiler also works successfully. If you want to allow certain type as element type of our matrix 2D, then you can add more list here. For example, this way we can put constraints of the element type of matrix 2D. So by using enable if allowed type T, we can control the element type that is allowed in matrix 2D. In my next episode, I will discuss optimization technique using MEMCPY and parallel algorithm. Please subscribe to my YouTube channel. Thank you for watching.